Geometry 6-1. We need to define the interior angle and exterior angles. So an interior angle is an angle formed at the vertex of a polygon. And an exterior angle is formed by a side and an extension of an adjacent side. So looking at this picture, interior angles would be these, 1, 2, 3, 4, 5. And then an exterior angle is formed right here using the edge of the triangle and then an extension of one side. So I can form one on this side or I can form one on the other side, but I really only have one per vertex. Consider the diagram. How many interior angles are there and how many exterior angles are there? Part B, how many unique exterior angles are there? And what is the relationship between interior and exterior angles? I want you to think that through and answer those on your own, as this is an explore and reason, which is supposed to be something you think through on your own. We have another definition here of a regular polygon. And a regular polygon is both equilateral and equiangular. So equilateral is all the sides the same, and equiangular is all of the angles the same. A couple more definitions. Convex and concave. These should be review definitions for you, but let's go ahead and talk about what they mean. In geometry, no diagonal, I guess I only need one, contains points outside polygon, and a concave, a diagonal, contains points outside the polygon. So this one, it's important to see no diagonal outside, and this one is diagonals outside. And a diagonal, in case you need a definition for that, thought I switched my pen. Is a segment that connects two non-consecutive vertices. Okay, so a diagonal would be from this corner to this corner, or this corner to this corner, this corner to this corner, this one over to here. We could draw all of the diagonals in there, but none of them are going to be on the outside, which means that this is convex. This one, I could draw from this corner to this corner, and that would be on the outside. So we see that this one is concave. This one is not a polygon. The next one is concave. And the next one is convex. That takes us into example 1. How does the number of sides of a convex polygon relate to the sum of the measures of its interior angles? So this is a picture of what kind of polygon? Well, this is a triangle. And the number of sides is 3. And the number of triangles that I can create by connecting vertices is just 1. And we know that the sum of those interior angles is 180. This next shape is a quadrilateral. It has 4 sides, so that is a quadrilateral. And we're talking about how many triangles can I create if I just have no lines crossing each other. I can draw from here to here, or I can draw from here to here. Either way, I'm going to end up with 2 triangles. And if I have 2 triangles, then that's 180 plus 180, which is 360 degrees inside. The next polygon has 5 sides, and so of course we call that a pentagon. And we can create, by drawing our diagonals, we can create 3 triangles. Well, 3 times 180 is 540 degrees. And a 6-sided one is a hexagon. We can draw 1, 2, 3 diagonals. That leaves so this is 6-sided. We can draw 4 triangles, which is, yes, another 180 degrees, 180, 180, 180, 180, and that comes out to 720 degrees. So how does the sum of the measures of the interior angles relate? Well, let's look at the pattern here. We have 3 sides makes 1 triangle, which is 180 degrees. So if n is the number of sides, we can subtract 2 and then multiply times 180 degrees. So we don't need to draw out every shape. So go ahead and, using this information, pause the video and try to come up with an answer for the triad. Looking at triad A, it asks how many triangles are formed by drawing diagonals from a vertex in a convex octagon. Well, 8 sides minus 2 would be 6 triangles. And what is the interior angle sum for a convex octagon? Well, this is where we would use the n minus 2 times 180. And so we have 6. So if n is 8, that's 6 times 180, which equals 1080 degrees. Let's go ahead and formulate that into a theorem that says the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180.